Hey, this is Lisa.
And I'm Steve.
And this is our Harmony Machine project. So here's our circuit. Right here is a microphone that takes in whatever note is coming in. And then that's amplified by this circuit right here, which is an inverting amplifier circuit using an op-amp. Output of this circuit is right here, which goes to the oscilloscope here. The oscilloscope takes the fast Fourier transform of the incoming signal, and then here in our LabView code, this takes the FFT from the oscilloscope, determines the dominant frequency, which is the frequency having the largest amplitude, and then we determine a harmony, which is a minor third below the dominant frequency. Here, that desired harmony frequency gets converted into an angle, which we had to do some calibration and MATLAB fitting in order to determine. And then from there, it's a lot of code to get the motor to move through that angle and recognize that it's actually there and stop. And we have some lovely graphs. This right here gives us the motor position as a function of time. And this right here gives us the dominant frequency that's being detected as a function of time. From the LabView code, that goes to the NXT, which powers our motor. This motor in this fancy setup turns this potentiometer, which in turn changes the frequency of an oscillating circuit governed by a 555 timer. So that frequency finally goes to these lovely speakers here to make a incredibly pleasant tone, which we tried to make even more pleasant with use of this capacitor to filter out some of the awful high-pitched harmonics that happen. So, some of the things that we learned in doing this project are...
One thing we learned was that you can use a capacitor to filter out a DC signal when you have a complex signal coming in from like a microphone. You can use the capacitor to essentially set the DC offset to 0 so that you only get the oscillating signal from the alternating current.
And then another thing that we learned that we didn't know before is how to communicate with external devices through GPIB, which is invaluable. And then a third thing we learned is about how you can use well, I guess we already knew it, but we kind of forgot it, about how you can use a capacitor to also filter out the higher frequencies of a signal as a low-pass filter, if you will.
Yeah, lots of valuable stuff we learned.
Because we're awesome.
Yep.